Okay, let's look at a few examples of how to use the quadratic formula to solve equations. Recall, the quadratic formula tells us that if we have a quadratic equation that looks like this, ax squared plus bx plus c equals 0, then that equation is solved by x equals negative b plus or minus, we have two solutions here possibly, the square root of b squared minus 4ac, all of that over 2a, where of course the a and b and c are the same constants you see up here in this equation. Okay, so let's see how this plays out in practice. Example number 1. Suppose we have the quadratic equation 2x squared plus 2x equals 7. Okay, so first, in order to apply the quadratic formula to solve this, we need to have our equation in this form right here, where we have 0 on the right-hand side, okay, or at least on one side by itself. Here we have a 7 over here. So let's subtract that 7 off of both sides to get 2x squared plus 2x minus 7 equals 0. Now we have it in the right form. So our a is of course 2, our b is this 2, and our c is negative 7. So now it's very direct, right? We can just plug in to this formula to arrive at x equals negative b. Well, that would be negative 2 plus or minus the square root of b squared. Well, we said b was 2, so that's going to be 4, minus the product of 4 and a and c, which are 2 and negative 7. All of that over 2a, which would be 4 here, right? 2 times 2. All right, so we have the solution. It's just not in simplified form yet, so we can clean this up a little bit. Of course, that's negative 2 plus or minus, cleaning up the inside here. Actually, if you look at the factors here, that might save us a little bit of time. Both of those have a factor of 4, so I'm going to factor that out, and that's going to leave 1 minus the product of 2 and negative 7, so those two negatives become plus, and then of course we have 14. All of that over 4, which is negative 2 plus or minus the square root of 4 times 15 over 4. Okay, now I did this little factoring trick here because realize where we are headed. We're taking the square root of something, whatever this number is. We'll want to make sure that we have the square root completely simplified. That's going to mean that we need to look at the factors and pull out any perfect squares. 4 just happens to be one of those perfect squares. So I can write this as 2 times the square root of what's left, which is the square root of 15. So we have negative 2 plus or minus 2, that's the square root of 4, times the square root of what's left, that's the square root of 15, all of that over 4. Okay, so now in terms of this radical, that's been completely simplified. However, this whole fraction is still not completely simplified. Notice the factors of the denominator, that's 2 times 2, and we can pull out a factor of 2 in the numerator. All right, so this is going to be 2 times, let's see what's left, negative 1 plus or minus square root of 15, all of that over 4, and now we can cancel there. And so finally we arrive at our answer, our simplified answer, negative 1 plus or minus the square root of 15 over 2. Okay, so the quadratic formula is great in that even if the equation here doesn't factor nicely, and by the way, if it should factor nicely, you should almost always go that route because you'll save a little bit of work. But the quadratic formula gives us a way to deal with quadratic equations where things don't factor nicely. There is some work on the back end though. We get immediately to a solution, but then simplifying that solution might take a little bit of work. Okay, all right, let's look at another example. Okay, how about x squared minus x plus 2 equals 0? This will be example number 2. Okay, so here again, we really should be checking to see if things factor first before we pull out the quadratic formula. although this is quick to check in this case. Of course, you would have x and x here to get x squared if this is the product of two binomials. And to get this 2, we're pretty much going to need a 2 and a 1. Okay. Notice this plus tells us these two guys have to be the same sign. However, if they're the same sign, there's no way to get a negative x term, right? You either have plus 2x and plus x, that's 3x, or you have negative 2x and negative x, that's negative 3x. There's no way to get a single negative x. So factoring doesn't appear to pan out in this particular situation, and so we'll use the quadratic formula. Okay, remember that says if you have ax squared plus bx plus c equals 0, then x is negative b plus or minus the square root of b squared minus 4ac, all of that over 2a. All right, so here our a is a coefficient on x squared, that's a 1. Our b is a coefficient on this guy, which is negative 1. And our c is, of course, plus 2. So that tells us x is going to equal negative b, so positive 1, plus or minus the square root of b squared, which is also 1, minus 4ac. Notice a and c are both positive here, so we end up with minus 4 times 1 times 2, all that over 2a, or just 2. But look what we have under the radical. If we clean this up, isn't that 1 minus 8, or negative 7? This should bother you, right? We can't take the square root of negative 7 and get a real value. Okay, so at least over the reals, this particular quadratic equation has no solution, or no real solution. Okay, the solution set is empty. We might write it that way as well. All right. Okay, one more example here. Suppose we had x squared minus 6x plus 9 equals 0. Okay, so if we apply the quadratic formula right away here, and of course we know better, right? We know we should be checking for factoring first, but if we did, then notice, of course, a is equal to 1 here, b is equal to negative 6, c is equal to 9, the constant term. Okay, and so we can go immediately to x equals negative b, which is going to be positive 6, plus or minus the square root of b squared. Let's see, that's going to be 36, minus 4 times a times c, all of that over twice the value of a, which is just 2. This, of course, we can clean up. That's 6 plus or minus the square root of, let's see, we have 36 minus 4 times 9. That's 36. Aha, something interesting here happens. That's 6 plus or minus the square root of 0, which of course is 0. That means this radical term drops off. You're adding or subtracting 0. It doesn't make a difference which one of those you do. You're still left with only 6 in the numerator. So this is just 6 over 2, or 3. Okay. Now, we're getting the right value here, the right answer. We can plug that in and check it if you wish. But there was a simpler way here. Remember, we should check to see if this thing factors first. If we had, isn't this just x minus 3 squared on the left? And if that's the case, doesn't x minus 3 have to be 0, which means x is 3? Notice how much less work that was when we went the factoring route. Okay, so the quadratic formula is useful, but check for factoring first. Okay, either way, our answer in this case is 3. All right.